Hello, everybody. So by now you have completed the first part of the Nearpod, which was where you were looking at how can we interpret a given p-value. Remembering that we fail to reject the null hypothesis if the p-value is greater than the significance level, and we reject the null hypothesis when the p-value is less than the significance level. So now I'm going to show you an example of how we can use those formulas to actually find our significance level. So remember that we do have a formula sheet for this, and that's what we're going to be using. So first, let me show you the problem. So let's read through this problem together. It says, a century ago, the average height of adult women in the United States was 63 inches. Researchers believe that the average height might be greater today. A random sample of 40 adult women was selected from the population. The sample had a mean of 64.2 inches and a standard deviation of 2.9 inches. So those are our sample mean and standard deviation. Assuming all conditions for inference are met, the researchers will perform an appropriate hypothesis test to investigate their belief. And they are asking which of the following is the correct test statistic for the hypothesis test. So notice that we have a few important things going on here. I always want to look back at the problem to see what information I can get. I know that the average height, so we're looking for the mean, is 63 inches. And I know that in a sample of 40 adult women, they found that the sample mean was 64.2 inches. So now I'm actually looking at the population mean, 63, and the sample mean, 64.2, and then that standard deviation of 2.9 inches. So we're going to use these to find our test statistic. And this is where I want you guys to go to Schoology. And if you click on class resources, you have your formulas for confidence intervals here. And when you open those, you can kind of look at, first of all, if you're not sure which formula you should use, you can say, okay, am I doing a confidence interval? No. I'm doing a significance test. Am I using a proportion or a mean? Well, we know we're looking at the average, so I'm looking for a mean. And then this question, which we will go into more detail next time, are we looking at one mean or a difference of two means? And we're only looking at one because we only took one sample. So I'm going to look in the fifth row of my formula sheet. Row 5 is for a significance test of a mean. So we're testing if the true mean is the same as our hypothesis. And we're going to use this formula. So we're calculating the t-value, and we need to do the sample mean minus the population mean, all divided by the standard deviation, that's the sample standard deviation, over the square root of n. Let me zoom in case you can't see that very well. This is what this formula looks like. So I'm going to go back to the other page and look for the sample mean, population mean, standard deviation, and n, the sample size. Okay, so here my x bar equals the sample mean, which is that 64.2. My mu, which I'm just going to write a u, that's my population mean, the one that we are using to test our hypothesis, that's 63. My standard deviation, I'll make that an S, that is the 2.9 inches that we saw. And then the last thing that I need to know is what's my sample size? And I asked a random sample of 40 women, so that means that n equals 40. These are all of the variables that I need. And remember, it's going to be sample mean minus the population mean on the top, all divided by, and then we'll have another fraction, which is the standard deviation S, all over the square root of n. And something that I like to do when I'm doing this is to actually include parentheses on the bottom, just because I want to remember that it's going to be plugged into my calculator, right? When I plug into my calculator, I need to have those parentheses. All right, this is my formula. If I want, I can draw my bars over the x to remind myself that that is a mean. I'm just going to plug into this to get my answer. So I've now plugged everything in, and these are the numbers that I found. I'm going to plug that into my calculator and see what I can find on that one. When I plug this into my calculator, I got 2.18. And I will show you on my screen, I did plug it in with parentheses around the top and bottom part of that fraction. 2.18. And something that I forgot to write at the beginning of this is, what are we actually finding? And that is our t value. So all of this is with t equals. So we have t equals, when we put our formula, plug everything in, and calculate the number. Notice that on this multiple choice question, they didn't actually ask you to calculate the number. They just asked you to plug it into the formula. So our answer for this one would be E. We just went a step further. And now that we have that 2.18, we can actually look up and see what is the p-value, because right now we still don't know what our p-value is. And remember, that's the thing that we are comparing to find out, is the p-value greater than or less than our significance level? If I want to do that, I'm going to use my other resource that I have for you today. So I'll clear this. Go back to class resources. And if you look in here at the t-score table, and you might have to click to make it go out to another page to show up. This table is showing you a bunch of different t values, like the number that I had, and you're going to be able to look them up in the center of here and find out what is the corresponding p-value, or the corresponding tail that we see up here. If it is less than our significance level, which is usually 0.05, then we know that that is going to be a significant result. So let me look on here for my own. Remember that whenever we're looking at t values, we need to think about degrees of freedom. And degrees of freedom has to do with the number in our sample. This was a random sample of 40 people. So we're going to look near this 40 column. Ideally, we would want 39, but this is actually kind of an estimate. And we're looking for a value of 2.18, which in this one is going to be somewhere between this 2.02 and 2.423, right? So again, this is kind of an estimate. The closest thing that I could get was that 40. And then from that 40, I'm looking all the way over here and I'm going to say, well, it's probably somewhere between these two values for my z, which means that I'm going to be looking all the way up to the top of here and looking at my t-test. So this is a one-tail test, which just means we're only looking in one direction to see, is the p greater than or less than this thing. And what I see here is that my p-value is going to be something between 0.25 and 0.01. I don't know what it is exactly, but I know for sure that either way, that's less than 0.05. So when I'm looking at this problem, I know that my p-value is somewhere between that 0.025 and 0.01. I'm going to say, it doesn't matter exactly what it is, but I can conclude then that because the p-value is less than alpha, the significance level of 0.05, I'm going to conclude that we reject the null hypothesis in this case. And we do have convincing evidence against the null hypothesis. You're going to be doing the same thing for yourself. So remembering, let me clear this. Whenever you're looking at a problem, remember you need to think about, is it the average or the proportion? Choose the correct formula. This is the one for proportion. This is the one for mean. Plug it in and then compare on this t table if it's a mean, or you would use the z table if it's a proportion. So you have t-score table, and you also have z-score table here. For your own work today, you are going to be answering a similar question as an open-ended question, so trying to solve just for the t-value, and then you're going to create a short video to explain your answer. All right, that's it for today. Once you guys finish the next two activities, you are done. Thank you all. Please let me know if you have questions. I will check my email this afternoon.